Section 7.5, Exploring Angle Pairs. On the key concept at the bottom of page 466 and the top of page 467, we have 4 vocab words that we must make note of. So we're going to start with the first definition. Adjacent angles are 2 coplanar angles with a common side and a common vertex, but no common interior points. You may have also heard that adjacent means next to each other. So that is an easier way to explain adjacent angles, but you have to realize that next to each other means that they share a vertex and a common side, which in this case is this ray. So 1 and 2 would be adjacent angles. In the second picture, angles 3 and 4 would be adjacent angles because they are next to each other, they share a common side and a vertex. Vertical angles are 2 angles whose sides are opposite rays. So basically what you have to have with a vertical angle is we're going to have 2 intersecting lines or segments, and then the angles across from each other are vertical. So for example, angles 1 and 2 are vertical, and angles 3 and 4 are vertical. Something that the book does not tell you in this definition is that vertical angles are congruent. So I do want you to write that down. For example, angle 1 and angle 2, they are congruent. Angle 3 and angle 4 are congruent. They are across from each other. They are vertical angles. The next 2 at the top of page 467 are complementary angles and supplementary angles. Complementary angles are 2 angles whose measures have a sum of 90. Each angle is called the complement of each other. As you can see, there are 2 pictures. In the first picture, angle 1 and 2 make a right angle, therefore they are complementary. They do not need to be next to each other, however. As you can see, angle A and angle B are also complementary. They add up to 90 degrees. Supplementary angles are angles that you have 2 angles whose measures have a sum of 180. Notice that there are 2 angles. You can't just say angles are supplementary. It's 2 angles whose measures have a sum of 180. In part A, in problem 1, identifying angle pairs under the Got It section. Use the diagram at the right. Is the statement true? Explain. So A, angle AFE and angle CFD are vertical angles. Let's see. A, F, and that's F. AFE and angle CFD. Are these 2 angles vertical angles? Yes, they are. Now the reasoning, you could say a couple of things. You could say that the angles are across from each other, but more importantly, you would say that they are formed by opposite rays. And what that means is this. Here we have an opposite ray of this one. Here's another opposite ray of this one. Remember, 2 opposite rays make a line. So we have 2 lines, and the angles across from them are your opposite rays that make up those angles. So yes, why are they vertical? Because they are formed by opposite rays, which in case would be FA, ray FD, ray FC, and ray FE. You don't need to name the rays, but they are formed by opposite rays. B, angle BFC, which is this one right here, is 28 degrees, and DFE are supplementary. No. Why not? Because one angle is 28, the other is 118. They do not have a sum of 180 degrees. You could also mathematically show me that they are not equal by doing that. 28 plus 118 is not equal to 180. C, angle BFD, which is 28 degrees, and angle AFB are adjacent angles. Absolutely, they're next to each other. So yes, why? Because they have a common side and common vertex. Common side and common vertex. On page 468, problem 2, we're going to start by making conclusions from a diagram. So let's read the concept summary together. There are some relationships that you can assume to be true from a diagram that has no marks or measures. There are other relationships you cannot assume directly. For example, you can conclude the following from an unmarked diagram: that angles are adjacent. Angles are adjacent and supplementary. Angles are vertical angles. You cannot conclude the following from an unmarked diagram: that angles or segments are congruent. You cannot conclude that an angle is a right angle. And you cannot conclude that angles are complementary. So I want you to write or draw this drawing. Let's put it right next to the concept summary. So here's your drawing. I want you to list the things that you can conclude from the information in the diagram. So we're going to start with the first thing. What can I conclude? We can conclude that angle 1 is congruent to angle 2 because it tells me in the picture that they are marked, that they are congruent. So angle 1 is congruent to angle 2. We can conclude that angle 3 and angle 5 are vertical. We can conclude that angle 1 and angle 2, angle 2 and angle 3, angle 3 and angle 4, angle 4 and angle 5, angle 5 and angle 1 are all adjacent angles. We also can conclude that angle 3 and 4, this is important, angle 4 and 5 are supplementary. Why is that? We can conclude that they're supplementary because they make a straight line. A straight line is a straight angle that's 180 degrees. 3 and 4 have to be supplementary, and 4 and 5 have to be supplementary. On the bottom of page 469, we're going to look at the gray region together. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. The angles of a linear pair form a straight angle. So a linear pair is a pair of adjacent angles, angles that are next to each other, share a common side and vertex, whose non-common sides are opposite rays. That means that ray BA in that picture and ray BC would form a line. They are opposite rays. So here's postulate 9. If two angles form a linear pair, then they are supplementary. Basically what that means is if you have two angles that make a straight line, then we know that those two lines are going to be supplementary, which means they add up to 180 degrees. On the top of page 470, problem 3 says finding missing angle measures. So I want you to write this down under the got it problem at the top of the page. It says that angle KPL and angle JPL are a linear pair. The measure of angle KPL is equal to 2x plus 24, and the measure of angle JPL is equal to 4x plus 36. Find their measures. So the first thing I would always suggest is always try to draw a picture. Since they're a linear pair, we know that they form a straight line. So KPL and JPL, notice that they both share PL. So P obviously has to be that, the vertex, and ray PL would have to be the common side. So then KPL could be this, and JPL would be that angle. So we know that the measure of angle KPL is 2x plus 24, And the measure of angle JPL is 4x plus 36. So now we have to write an equation. We know that they make a straight line, which means they add up to 180 degrees. So I can add them together. 6x plus 60 equals 180 degrees. Now solve this simple two-step equation. Subtract 60. You get 6x equals 120. Divide by 6. The value of x is 20. But I don't want to know what the value of x is. I want to know what are their measures. So now plug them in. 2 times 20 is 40, plus 24 is 64. So we know the measure of angle KPL is equal to 64 degrees. The measure of angle JPL, 20 times 4 is 80. 80 plus 36 is 116. Those two angles add up to 180, so we know we did it correctly. 64 degrees and 116 degrees is your answer. Now, part A says, how can you check your results? Well, do they add up to 180 degrees? They do, so we know we did it right. So why don't you try B on your own and then see what you get. If you did it correctly, you should have the equation 5x. No, that's not right. You should have the equation 5x plus 3x, which is 8x. 14 minus 2 is plus 12 equals 180 because they add up to 180 because they make a linear pair. If you solve this equation, you're going to get the value of x to be 21. And if you plug 21 into both of those, you are going to get the measure of angle ADB as 77 degrees and the measure of angle BDC as 103 degrees. On the top of page 471, angle bisector is another vocab word. An angle bisector is just like a segment bisector. An angle bisector is a ray that divides an angle into two congruent angles. Its endpoint is the angle vertex. Within the ray, a segment with the same endpoint is also an angle bisector. The ray or segment bisects the angle. So if you just look at the example, we have ray AY bisects the angle XAZ. Therefore, the two inner angles, XAY and YAZ, are both congruent. So let's do the got it problem on page 471. Ray KM bisects the angle JKL. So I'm just going to quickly draw a picture. JKL is bisected by KM. Therefore, we know that these two angles are equal. The measure of angle JKL, the whole angle, is 72 degrees. What's the measure of that angle? If it bisects it, it cuts it in half. So 72 divided by 2 gives me 36 degrees. That's it. So let's do practice 7 together. On page 471. Look at the diagram, and it says that ray GH bisects the angle FGI. Solve for x and find the angle. So if we're going to solve for x, that means the angles are equal. So we're going to do 3x minus 3 equals 4x minus 14. Solve this equation. We're going to subtract 3x on both sides. We're going to add 14. So the value of x is 11. I plug it in for either one. It doesn't matter because they're going to be the same. So if I take 3 times 11 is 33 minus 3, the measure of angle FGH is going to be 30 degrees. So then B, what is the measure of HGI? Well, it's the same thing. It's 30 degrees. And C, what is the measure of the entire angle? Well, 30 plus 30 gives me 60 degrees. So our vocabulary review for this chapter, section 7.5, are adjacent angles, vertical angles, complementary angles, supplementary angles. All 4 of those are pairs of angles, such as adjacent angles, pair of angles that share a common side and vertex. Vertical angles are angles that are across from each other when you have two opposite rays that form two lines. Complementary angles are two angles whose sum is 90 degrees. Supplementary angles are two angles whose sum is 180 degrees. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. Basically, they form a straight angle or a straight line. An angle bisector is a ray that divides an angle into two congruent angles.